Hello and welcome back to Azure Terraformer. Last episode we continued the saga of the Minecraft Terraform saga on Azure by setting up our production pipeline. Today we're going to be extracting our Minecraft server into its own module so that we can very easily stamp out a new environment with minimal inputs. If you like this content and you want to see more of it, please hit like and subscribe and smash the notification button to find out when my next video drops. And without further ado, let's get going. So looking at my code, I am going to basically take my my blob storage. Let's start with my blob storage module. Okay. So I'm going to create a new module folder, and we're going to call this Minecraft. And we are going to create a new folder called Blob Storage Backend, because that's the back end of our Minecraft database, of our Minecraft server. We're going to have main. I'm going to grab my versions file here and drop it in there. For a non-root module, you should not declare a provider block, and you should not declare a backend, because you're going to, leverage, the one provided to you. I don't think we're going to need the random provider, so I'm going to drop that. And I'm going to modify my variables here, but I'm going to leave that as a placeholder for now. So this is my blob storage backend for my Minecraft server. So the things that I need are basically right here. So I'm going to grab all of this and just move that in here. Okay. Now the paths are going to change for these modules, because now these module references are now a module in their own right. And I've got a little bit of a some nesting going on here. So if we think about the dots, right, this has got to be relative to my current location. So if I'm in blob storage backend and I do one ... I'm going to be in the Minecraft folder. If I do two ... I'm going to be in the modules directory itself. And so if I no longer need this, I just need one more ... And now this ... basically means I'm in the modules directory, and then from there I can go to the VM folder and the Linux public, and I can grab that. So any reference to peer modules needs to just have ... and I don't need the modules directory anymore at all. And there's only one module reference here, so I should be good. Yep. Okay. So now what do I need to do here? So I do need an image version. Now, because this is relative to, basically I'm isolating the blob storage Minecraft server into its own module. And so we have one data reference to a virtual machine image. So we're just going to do, we don't need that prefix there. It's just going to be image version and image name. Okay. And this is going to be our Minecraft image. I can leave that reference the same. It's fine. It really doesn't affect anything, but I do need a location. I need a name. I am going to need a resource group, because I no longer have access to that. I'm using this thing here. I'm gonna need the identity. So let's go ahead and bring in the identity. So that's additional code that we need to bring in here. And I just need to bring this because this is just the blob storage identity. And so as we extract, as we pull out these values from our root module becomes inherently simpler, because we're compartmentalizing that logic and those resources into this module. And in this case, so I'm going to bring the storage account in here as well. RTF, because if I'm deploying a local storage Minecraft server, I don't need an Azure storage account to store the worlds. So this resource really only makes sense within the context of this project. So from here, I'm going to go, the resource group has to be a var, resource group name. The location is going to be a var as well. And if you keep your resource group name and your location together, you can pretty much copy pasta these two attributes. That's one of the common things that happens to all of your resources, is that, you know, I didn't do it here, but all of these values ultimately become extracted as variables, because you want to target an existing resource group and the location of that resource group. Now the VM image, the data reference I'm leaving in there. The SSH key, I think I should pass that in as a variable. SSH public key. And then the managed ID, I declare that in this module. That'll stay the same. And then the module for the VM stays the same, and the storage account's declared in this module. So I think we should be good there. Okay. So now here, let's check the storage account. Let's check the identity. We need to update these. So we're going to fix those. And the storage account is created in here, and the identity is created in here. So I think this should be good as well. So now what variables do we need? And a lot of times you can grab your starter variables from the root module where you originally had all this stuff hard coded. So my Minecraft image version, all these things are gonna be input variables here. I'm just gonna change the names because I don't need that specificity anymore. We get the image name, the image version. We get the gallery resource group, the gallery name. These all need to be variables. We have the name, but we also need a resource group name. It's usually a good idea to provide a name that can be used to embed within, within all of your resources when you deploy a module. That way, the client of your module can kind of control how things are named. So here, like, I'm no longer getting the random string here. And actually, I probably should generate my own random string inside this module. Otherwise, I'm gonna probably run into some problems here. Yep, so we're gonna generate our own random string inside this module for that storage account. I'm glad I caught that. And so where is name going to be used? Let's check where var.name is being used. So var.name is being used in the virtual machine name. What about the identity? It's being used in the identity. Whoa. And we got this random string here as well. I think we're just going to leave that with the var name. And when we pass in the name of this thing, we're probably going to pass in the random string anyway. But and actually, you know what? I might just use the random string that we also use with the storage account to keep that simple, so that these environments can be kind of isolated. So I'm going to promote my random string into main, because I'm going to use that as kind of a key resource. It's going to be used to uniquify my identity and my storage account. And that way my host name can be very clean and unique, because the host name does not need to be global unique. It's not like an active, the identity shows up in Azure Active Directory, so it has to be unique, and the storage account has to be unique because it has to be globally unique DNS. So it's very, very important that those are unique. So I think I'm pretty good right now. So if I look at what I've done, this is pretty much gone. Now let's just declare my module. And this is going to be my my Minecraft blob storage server. And my source is going to be relative to the root directory, which is modules Minecraft Storage Backend. And then the variables that I need to pass are the location, which is just, I'm piping in, from Azure RM, resource group name, and you know what, just to keep the dependency graph clean, I should probably set the location off of the resource group location. You don't have to do this per se, but it does keep things neat and tidy, and it states very clearly that the resource group and the location must match. And so now the name here, I'm just going to call this Minecraft blob. That's what this guy's going to be called. So let's open on the side. So what else do we need? We have location, resource group name. We need the gallery name. That should be coming in from var.gallery. The gallery resource group should be coming in from the var. And then we should have an image name, which is going to come in from var, but it's going to be a Minecraft blob image name. And then we're going to have an image version, which is going to come in from kind of the same place, Minecraft blob image version. And so let's get all these to line up. Oops. What happened? Okay. So yeah, so basically all of this stuff, the identity, the storage, the VM, which I'm reusing my module and just adding a custom script extension on top of that, it's going to get encompassed in here. Now I also need to copy my files, right? Because now my custom script extension is going to be using this file, but I only need one file in here. So again, we're compartmentalizing all this logic that's related to the Blob Storage Backend into one place. Okay, so this should be good. Oh yeah, we do need the SSH key, don't we? So we need this variable for the SSH key. So variable SSH. There we go. And let's not forget to add that here. And that value we pull from our TLS resource. Okay, we might have missed something, but we'll go back and fix it later. Now I'm going to create a module for my local storage backend. So we're just going to create a new folder, local storage backend. And now I'm going to take all of my boilerplate, put it in there, add a new file for main. Okay, this should be pretty much the same inputs, just with some different resources in the main. And we have to refactor this to use the generic image version and image name, because this will be piped in. We're going to have to change this to the var resource group name. This is going to go to var. The managed ID stays the same. The VM image reference stays the same. The custom script extension stays the same, but we do need those files. And we only need the local storage one, which is pretty simple. And we no longer need the files in the root module, so I'm going to get rid of those. And let's see here. I think that's pretty much it. So I can copy this module reference, paste it here, and instead of blob storage, I'll call it local storage, Minecraft local, and then this is going to be the Minecraft local image, the Minecraft local image version. We're still going to use the same SSH key. We're going to still use the same gallery. We're going to still use a resource group. And we should be good to go. So now, one thing I noticed, like we're not piping in the subnet. So let me go see what's going on there. There should be a subnet ID coming in. And it is, but it's coming from a module, but that module doesn't exist within our current scope. So we're going to have to var subnet ID that in for both of these modules, because we don't want to create the network within the same module. And I'm just going to add an attribute here called subnet ID, and we're going to set it to the same value that it was, because this module network is within the same scope in the root module. So we do have access to it here, but within the module itself we do not. So I'm going to add a variable to pipe that in each of these modules, and we should be good to go. Okay, so let's just do a little round of double checking. I don't think there should be anything there. We can delete our storage. The key vault, you know, we're passing in the SSH public key, and our Packer images have been working, and our custom script extensions have been working perfectly. So I haven't had to SSH in the machines to like fix anything. So that's positive. The key vault, this is just setting up the key vault and the access policies. The identity, we almost forgot that for the local one. We do need the local identity, and I think that one also uses a random string. So let's just generate a random string for this guy anyway. That way we can guarantee uniqueness anytime we pump out one of these modules. In real life, I probably would extract that managed identity out and just reuse the same managed identity. But in this case, for the blob storage, for the blob storage backend, I think it makes a lot of sense, because then that managed identity has least privileges. It only has access to the storage account for the Minecraft server that's using it. So in that case, I think it is ideal. And now identity's gone, so I can delete that. So our root module has become extremely simple. And I'm just going to collapse this down. Why do I need 2 files for like basically 10 lines of code? I'm going to delete that file, and I'm going to just rename all of this stuff just Minecraft, because that's what we're doing. And we're to deploy Minecraft, we're just deploying 2 modules: our blob storage server module and our local storage server module. And we are using the right module. We're giving it a different name. Of course, we are generating random strings within those modules respectively, so it should be all right. So I'm pretty happy with this. Let's go ahead and run this and see what happens. So refactor Minecraft carved server into modules. There we go. And let's go run a pull request. And there's probably going to be a lot of stuff that's going to get deleted and recreated. that's one of the things. Modules are a structural element within Terraform, which does manifest down to the state level. So when you refactor something into a module, the layers of and sometimes multiple layers of modules, like modules within modules, that will manifest into state. Oops, we've failed to read okay, did I get my path wrong? I clearly, so it's looking for, and that's the trickiest thing with modules is the relative pathing. So I've got modules, Minecraft modules. So let's go check our path here. So Minecraft, so we're gonna go ... That's gonna take us out of V1 and up into modules. And then we're gonna go to Minecraft. And then from here, that, I mean, kind of looks good to me. Modules, yeah, Minecraft. What is it's like we've got a modules directory inside of our Minecraft modules directory, which doesn't make a whole lot of sense. So let's start removing some module references just to see what might be causing the problem. I think it might be related to the nested modules, like maybe my relative path inside this is not working. I probably should have got this working with just the Minecraft module by itself at first, but I got myself into this mess. So we're gonna get it out. Comment VMs. So let's just see what happens there. That'll update my pull request and it'll run up init and plan again. And that's probably going to fail on the validate because my virtual machine extensions are dependent on the VM. Yeah, should have known that. So let's go fix that. Save all. What's going on here? Sometimes Git gets like wonky in my Ubuntu server. I'm not quite sure why. But closing Visual Studio Code, yeah, VS Code, and then reopening it kind of clears whatever was hamstringing it up, clears it out of there. Trying to think if there's any other dependencies on the virtual machine module. Okay, we have fewer issues. So, okay, looks like we still have a resource reference in the local storage module under identity, which would be wrong. Yep, there we go. And here I can just go var location, and here I can just go var resource group name, and that should fix that. So fix managed ID for local. Okay, that should be good. And then let's see how that affects our pull request. It's going to rerun the check. Okay, so we have a pretty healthy plan right now. Of course, it's going to want to delete a whole bunch of things. Let's see if we can slowly bring back some of these things. Let's bring back the local VM and So yeah, there's definitely something up with our Minecraft folder for the modules. It's like modules, Minecraft modules. Let's look at this a little closer. I think I understand. Well, not really, because dot 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 out of v1, because we're in v1 right now. Dot 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 out of v1's put you in Terraform. Then you have to drop into modules. And then you have to drop into the Minecraft folder. And then you have to drop into the local storage backend. And then from here, we're gonna go, oh, I get it. We probably don't need this modules. That's the problem. So if we go dot dot dot, and oh, and this is just wrong. This is just wrong all around, right? Because I think we fixed it in Blob. It should be dot 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 dot. You know, 2 folders up, without a modules directory. Yeah, that. So I fixed it in Blob. Correct relative path to VM Linux. So again, the local paths in Terraform modules is it's kind of a tricky thing. Like it's painful. I wish there was so there is a module path, but there's no module root path, or source root, something like that. If you've got nested modules and you want to get to the root module. So now it could be we just don't have that variable declared. Okay, which makes sense. We did that in the Blob Storage Backend. Yeah, we have that. I just wrong name, that's all. And just an absolute wrong name. All right, so we fixed that. And let's go check our pull request again. We're getting close. We're getting real close here. We're debugging. This should be good, I think. Okay, looking good. In situations like this, there's going to be a lot of destroy and add. It's like drop create. So you can see we're pretty much deleting almost everything, and then we're recreating it. So like I mentioned, the module path is going to cause a replacement when you reconstruct. So refactoring into modules is something that you probably want to do a little bit early before you get stateful deployments going, because it will cause a drop create when you go to use it, when you go to use your module. But if you can keep your module path the same, small tweaks within that module, version changes within that module will not cause drop create. Bring back the blob. And this should be good as well. Let's see if we can bring back both the local storage backend and the blob storage backend. And it looks good to me. So let's go approve and merge that PR. Boom. And we will watch it deploy to dev. Okay, so it looks like our servers are out there. and this is our dev environment. So let's go test it. So we got dev local. Let's go connect. Now off screen, I updated the public IP address, but we'll see. Okay, so this is looks to be like a slightly different biome start position. Okay, let's try dev blob, and yep, definitely different start position. In looks like a bit of a birch and oak forest. And yeah, there you go. Okay, so there you have it. We successfully refactored our Terraform Minecraft code into two different modules: a module that deploys our Minecraft server with local storage, and a Terraform module that provisions Minecraft with a Blob Storage Backend. So, and then we reconfigured our root module, and we submitted a pull request, merged that in, and Terraform just figured out what it had to do and deleted what used to be there and deployed our new modules. So that's the process that you go through when you want to extract out common functionality into a Terraform module to make it much more reusable. And in the next episode, you'll see one of the main reasons and basically a superpower of this technique that makes it super easy to stamp out multiple environments across regions, and all over the place. So this next episode will be expanding this deployment and deploying those modules to a whole bunch of different regions. So hope you join me then. Please don't forget to smash the like button, subscribe, and hit the notifications bell so you can be notified when my next video drops. Really appreciate it. As always, thanks again from Azure Terraformer, signing out. Until next time.